This is Kyle Cox. This is Project 3 from Math in the Model World. I went with the correct diagnosis problem for the cancer testing. In the example given, this type of cancer has a 0.5% incidence rate, meaning 0.5% of the population would have cancer. It has the test in the example has a 1.4% false negative rate and a 1% false positive rate. In class, we went over a couple different methods for coming up with these probabilities. I liked method 1, the table method. It just makes more intuitive sense for me, and I can visually see things. Basically, given the information we have here, you just plug in the numbers. We're going to use 10,000 people as the population for this example. So starting with the incidence rate, 10,000 times 0.5% gives us 50 people with cancer. So the remaining 9,950 would not have cancer. The table allows us to add this up and get this total here, so you can confirm that that math is correct. The false negative, we had of the 50 people with cancer, 1.4% of them did not tested negative. I'm sorry. So the remaining would be 49.3. So those people tested positive and actually had cancer. Then the false positive, we have 1% of the 9,950 would be 99.5. So 99.5 out of this would be those that actually tested positive but did not have cancer. And again, you can double check your work by adding these up, and they come up to the 10,000. So the two questions at the end of this example, the first one was, based on the math from our table, a random person that tests positive would have a 33% chance of having cancer. We would find this by taking those that tested positive, 49.3 that had cancer, over the 148.8 of all positive tests. That comes up to 0.331 or 33.1%. And similarly, we would do for a person that randomly got a negative test, they would have a 99.9% chance of not having cancer. We did that by taking the 9850.5, those that tested negative without cancer, dividing that by 9851.2, which were the total negative tests. When you do the math, it comes up to 0.999 and then some, so 99.9% rounded up. So based on that, I would say that I would recommend using this test. It's very accurate for negative tests, and it's a very good frontline start, basically, for checking for this cancer. The false positives are a little higher, but that would all be confirmed in a real world setting in other ways too. So I would recommend it.